Haji Abu. Welcome to my YouTube channel. So in this video, we will discuss about estimates of location. Estimates of location. So what is mean by a estimate? So estimates mostly used by the statistician, which means the calculated value, the value that is calculated from the data in hand. So this value can be used to compare with the original value. Okay. So usually the computer science people call it as a metric. So here, suppose we have a set of data in hand. Okay. So we need to calculate the location where most of the data is located. Okay. That means like we need to calculate the central tendency of the data. So for that we usually use mean, median and mode. Okay. So in mean we have we can divide into like three categories of mean. Okay. We can have like a normal mean. We have trimmed mean. And we can have a weighted mean. Okay. So in this video, we will more concentrate on the mean. So let me clear the screen. Okay. So we can have the basic mean. So we all know mean means calculating the average. So which has a formula which is represented by x bar. Okay. It has a formula. You can say it like sigma I is equal to 1 to n x of I divided by n. Okay. This n means number of elements in that data. Consider, for example, consider we have a set of data 3, 5, 1, 2. Okay. Here we need to calculate the mean of the data. So which is like 3 plus 5 plus 1 plus 2 divided by 4, which is like I believe 8, 9, 11 by 4, which is equal to 2.75. Okay. Calculating mean is very simple, right? But the problem is like mean is influenced by the outliers. Okay. Okay, suppose another data set we have, say like 3, 5, 1, 2 and 100. Okay. See, this 100 is different from all other datas in this set. Okay, this is actually different. So this we will call it as a outlier. Okay. And we will discuss more about outlier in the coming videos. So now we can calculate the mean of the data. See, 3 plus 5 plus 1 plus 2 plus 100 divided by 5, which will be 111 by 5, which is equal to 22.2 approximately, right? So here we can see that mean of the, by just adding one data, the mean is actually shifted from 2.75 to 22.2. This is almost 10 times, approximately 10 times more than the normal data. So whenever we have a outliers, the mean actually shifting its central position. So this is one of the drawback of mean. Now we can discuss about trimmed mean. Clear the page. Okay. We will discuss about trimmed mean. Okay. So what happens in the trimmed mean? So in trimmed mean, what we will do, we will sort the data We will sort the data in hand, and we will drop fixed number of values from the both ends. Okay, so I will show you example. So take our previous example. We have 3, 5, 1, 2, 100 and minus 50. Okay, so before that, let me tell you, there is a formula for trimmed mean, that is x bar, which is equal to sigma I is equal to, we can say p plus 1, here n minus p x of I divided by n minus 2p. This is the trimmed mean formula. The first condition is we have to sort the data. So here minus 50 will be coming here, then 1, then 2, then 3, then 5, then 100. Okay. By analyzing the data, we know that okay, minus 50 and the 100 are kind of a outliers. So here, for example, we are setting p is equal to 1. Okay, if p is equal to 1, just apply the formula sigma 1 plus 1 and n minus p. Here n is 1, 2, 3, 4, 5, 6. N is 6. 6 minus, actually this is p, right? P is 1. 6 minus 1, then x of I divided by n minus, n is 6 minus 2p, that is 2 into 1. So here we can say that sigma I is equal to 2 to 5 x of I divided by 4. So we can check that. So here I is equal to 2. So we will be starting from 1. Okay. We will be starting from 1. So this is the index number 1. If you say, okay, this is the index number 1. This is index number 2. This is index number 3. This is index number 4. This is index number 5. This is index number 6. So we will be starting from 2, that is 1. So we will be taking 1 plus 2 plus 3 plus then 5 divided by 4. So this will be 1 plus 2 plus 3 plus 5, this will be 11. 11 by 4, which is equal to 2.75. See, if you guys are remembering, we are getting the same value as the mean. Okay, our earlier mean 2.75. So the trimmed mean actually really good for the outliers. It is like it will not be like much influenced by the outliers. Next is weighted mean. Let me clear the page. Okay, we have weighted mean. Weighted. So weighted mean have a formula. Let me first write the formula. X bar equal to sigma I is equal to 1 to n x of I w of I divided by sigma of w of I. Okay. So weighted mean is mostly used by if you want to give some kind of a weightage to some variables. For example, this is like we can mostly see in our like a examination. We know that for a specific category, I mean for a assignment, we will have some kind of a percentage, right? Percentage, some kind of a weightage will be there, and for Viva we will have some kind of a weightage. Suppose an example. Suppose we have some data. Suppose we have a assignment. We have assignment 1. Okay, its weightage is like, say like its weightage is 10%, and we have a grade 70%. So this is the grade and this is the weightage. weightage. So this is the assignment, and consider assignment number 2. Assignment 2 has also like 10 percentage of weightage and 65 percentage of the grade. Then for assignment number 3, suppose we have the weightage is 30 percentage, okay, and grade is 70 percentage. For the assignment number 4, it is 50 percentage and we have 85 percentage. Okay, now see how can we calculate this weighted mean. That is x bar, which is equal to x of I into w of I. Okay, so that is equal to 10 into 70 plus 10 into 65 plus 30 into 70 plus we have 50 into 85 divided by total sum of weights, which will be like 100. So this will equal to, we will have, if you calculate this, we will have 7700 into 100, and which will be equal to 77. Okay, this is how we calculated the weighted mean. Okay, so that's all in this video. Thanks for watching my video. So if it's useful, please do like and subscribe. Have a nice day.